Okay, we're going to do another stoichiometry problem that involves gases. And so if we talk about iron rusting, okay, for iron to rust, it's going to have to react with the oxygen in the air, which we know is a diatom. And it forms iron 3 oxide, which is actually rust. So if we think for a second what iron 3 oxide would look like, iron 3, oxygen's -2, so it takes 2 iron and 3 oxygen to match up, because the 2 gives us +6, the 3 gives us -6. We're balanced, or you're doing your good old drop and switch. Don't care how you get there as long as you get there. Okay, so I'm going to erase this for a second. All right, so we've now got our equation. So it's a synthesis and combustion reaction, so let's go ahead and balance it. I've got 1 iron, 2 iron. I could put a 2 there, but I can see I'm going to have a problem with oxygen. So I've got 3 here, 2 here, so I'm going to double this guy to get 6. That goes to 3. That now gives me 4 iron, 4 iron. So now we have a balanced chemical equation. So if I end up with 52 grams of iron that I'm going to use, okay, I want to know what the volume of oxygen would be to completely react all of this off. So how many liters, how many liters of oxygen gas would be produced? So we're going to start with 52.0 grams of Fe. I'm going to go grams of Fe to moles of Fe. My pen's causing problems, sorry. Go again, moles of Fe to moles of oxygen, and then go again, moles of oxygen to liters of oxygen. Once again, notice in this problem I did not give you temperature or pressure for anything, so we're using that 22.4. In another week or so, we'll start doing some other things if it's not talking about standard temperature and pressure, but for now we use that 22.4 conversion. All right, so moles to grams for iron. We're going to have 1, and then our mass for iron is 56. If you wanted to go more precisely, you could go the 55.85, but we'll just go ahead, call it 56. All right, so we've got this one, cross off our labels. Moles to moles, so we look at moles of iron. We currently have 4 moles of iron for every 3 moles of oxygen. So there's our ratio. Cross off, cross off. Moles to liters, we've said 1 is 22.4 liters. So we're going to multiply everything on top. So I have 52 times 3 times the 22.4, and then we divide it by 56 times 4 on the bottom. We end up with 15.6 liters of O2. 3 sig figs, so we're good. Now, if we wanted to go back 1, we could go 1.56 times 10 to the first liters of O2.